Hi, in this tutorial, I'm going to show you how to take a simple shapefile that looks like this, which has its longitude and latitude coordinate information in decimal degrees, and transform those information into something that looks like this, where those decimal degrees information get transformed into degrees, minutes, and seconds in this manner, and to display this information in a simple plot using Python scripting with the help of GeoPandas library. So let's go straight ahead into the tutorial. Let's get started by creating a new Python module. Go to File Explorer, right-click, and create a new module. This one I'm going to name as, you can give any name basically, this should be the name of your exercise. Decimal degrees to DMS. Alright, let's get started by importing a couple of libraries that we are going to use during the process. So first I'm going to get started by importing GeoPandas as GPD, and I'm also going to import the matplotlib library because later on during the second half of the exercise I'm going to do some plottings. So for that I'm going to require the matplotlib library. Alright, now if I go into this shapefiles folder, you can see that I have one shapefile called locations. So I'm just going to import that shapefile into my Python interface. I can create a variable called locations, and that's going to be equal to gpd.readFile. And from here I can directly give the full path to the place where I keep my locations shapefile. /locations.shp, and I would also like to plot it in order to see how it looks. Right, so let's hit F5 to run this command. And if I check over here, you can see that you can visualize the shapefile down under here. It's a point shapefile. And even if you'd like to see how the geodata frame looks, you can just open it from here. You can see that it's a point shapefile with the latitude and the longitude information over here in this special geometry column, which makes it a geodata frame, not a pandas data frame. All right. So the next thing that I'm going to do is create two more additional columns over here. I'm going to create one additional column saying that the longitude decimal degrees value and the latitude decimal degrees value. The decimal degrees value is basically this value. So I'm just going to extract this value and put it into a new column for longitude and latitude. So as you know, if you're working with the GeoPandas, the operations are quite similar to working with the pandas library. So if you want to create a new column in your geodata frame, what you would do is similar to what you would do if you were to work with pandas data frames. You just specify the name of your geodata frame and just specify the new column that you would like to add over here, which is I will name that as longitude _ decimal degrees, and that's going to be equal to locations. And now I will select the geometry column, and in the geometry column I'm planning to extract the x value. So this is how you would do it. Similarly, you can do that for latitude as well. Just to explain you a bit, you can see if I open over here, by specifying the name of the geodata frame, and if I specify geometry over here, that means it's selecting this column. And if I point to the x value, it's actually going to return the longitude value for me. And similarly, I can extract the latitude value as well. and that's going to be y value. All right, so let's run this one. And if I open this one over here, you can see that we already have two new columns, which has the longitude and the latitude values. All right. So the objective of this exercise is actually to transfer this longitude and latitude values into decimal degrees. So I'm going to do that in this geodata frame itself. So I'm going to actually create new two empty columns, and I'm going to name it as follows. Again, I'm going to select as locations, and only this time I'm going to select it as LON_DMS. So this is going to be the degrees, minutes and seconds values corresponding to the longitude. And for the time being, I'm just going to pass an empty argument, and similarly for latitude as well. All right, now you can run, and again you can open this one, and now you will see that we have two empty columns. Later on, after we convert these values into degrees, minutes and seconds, I'm just going to apply that value into these empty spaces. So that's the objective of creating these empty columns. So now I'm just going to apply the corresponding formulas and the arguments for longitude first. So I'll just put a comment over here, and first we are focusing about the longitude parameter. So the first thing I'm going to do is to iterate over the index and the row of this locations geodata frame. We can do that simply by using a for loop for index row in locations dot iter rows. And now I'm just going to pass a conditional statement. So now my conditional statement is going to be something like this. Before I go to the conditional statement, maybe let me just do a simple example and then show you how this loop works. Sorry, how this for loop works. So for example, if I just write something like print, and now if I print the row, I can just hit F5. Maybe for the time being, I'll get rid of this plotting because we won't need it. I'll hit F5 again. All right, now you can see that this information is corresponding to the first iteration. This is corresponding to the second iteration. So basically it's iterating over each and every row of this, and now you can see actually it's presenting the data in this format. So for example, if you look at this ID 0, station 1, geometry, this value, latitude, the longitude 103.721, latitude 1.3368, that's actually the information given in this row. So you can see that when we print the row, all of this information actually sort of getting printed out. This is how this index row in locations.iter rows work. So taking this into advantage, now I'm going to actually write my conditional statement. If row, and out of these things that are getting printed, I'm just going to select one column. So the way to select one column would be just to specify the name of the column inside these square brackets. So I'm going to specify longitude DD, and if this longitude value is more than 0, I'm going to specify the hemisphere to be east or west. So if it's more than 0, the hemisphere is going to be equal to east. If not, or you can just simply pass else if row if it's less than 0, the hemisphere is going to be west. Actually, using elif over here is not compulsory because the value is either going to be a positive value or a negative value. So if it's a negative value, you can simply specify here to be else instead of using elif, and you basically get the idea. For example, if I open the locations geodata frame, now you can see actually all the longitude values I have are positive, and that's actually corresponding to the eastern hemisphere over here. But if somebody were to actually import locations which corresponds to western hemisphere, these longitude values are going to be negative. So this particular statement takes care of that. All right, after we are done with that, now I'm going to create one variable called degrees of longitude. All right, now let's see how we can actually extract the degrees over here. Now, when we convert the decimal degrees into degrees, minutes, and seconds, and when you're trying to extract the value of degrees from this particular value, actually the degrees value is everything that's behind this decimal point. Now, if you were to strip out everything after the decimal point, and if you only isolate this integer over here, that's basically going to be your degrees value. So we will find a way to do that. Now, one way that I can think of doing that is basically, now if I do something like this, I think it'll be clear. So if I type here lon dd, you can see that actually the decimal degrees value of the last iteration, which is this one, will get printed. All right, now what I want to do is to actually remove this decimal part of this number and only keep this integer value. Now there's a library called math, and inside the library there's a module called modf, and that's doing exactly what we want. That's actually segmenting this number into two different parts: the part which is formed with the integer and the part which is formed with the decimal numbers. So in order to do that, we have to actually import this library called math. So we'll import that first. Import math, and I will run this command. All right, for the time being, I'll just put a comment over here and we'll run this. All right, now if I type here row lon td, you can see that we have this number, which is a decimal degrees value. Now if I do something like this, math.modf, and I use the same thing which I used here. All right, now you can see actually it sort of managed to segment the number into two parts. So by now you can guess actually this 103 plus whatever this value is going to form our final decimal degrees longitude value over here. But now if I check the type of this, you can see that it's actually segmenting the full number into a tuple. And now I'm only interested in this part. So how can you select this part? So for example, if I do something like this, by the way, you can go to the previous statements that you typed just by using the up and down arrows. So if I press the up arrow 2 times, you can see that I can arrive at the statement which I just typed over here. And if I specify 0 over here, you can see that it's actually selecting me the first argument in here. But instead of selecting 0, I can actually select 1. This is basically the index value. And if I select 1, you can see that it's giving me this value, which is exactly what I want. And I want to make sure that I always get a positive value for this particular value. So what I'm going to do is actually I'm just going to wrap this whole thing to be an absolute value. All right, that's not going to make a difference in this case, but in case actually if this value was a negative value, then when I put the absolute value command over here, it's actually going to transform that into a positive value. And finally, you can see that the value is now 103.0, but I don't want this 0.0. I just want it to be just the integer itself. And so in order to do that, we can actually transform this whole thing into an integer value. All right, now you can see it's a full integer now. So that's basically what I'm going to do over here. I think now, since I came here step by step, I think now you'll be clear of what I just did. So basically I'm going to copy the same thing over here and I will paste it over here and I'll remove this comment. So that's going to get us the decrease value in the form of an integer. So I can just simply run this one and see what happens. If I open this decrease.lon, decrease_lon, you can see that we managed to extract this decrease value already. All right, now let's come to the minutes part. Now let's see how we can dissect the number in order to derive the proper minutes value. So I'm just going to create another argument called another variable called minutes, but this is for longitude again. So again, I'll use this IPython console for you to sort of show you how we arrive at the statement finally in order to extract this minutes value. So I'll get started with again by typing row longitude decimal degrees. You can see what we get. We get the full number over here. And now I'm not interested in the integer part. I'm actually only interested in the decimal part. So we can do something similar to what we did over here, but instead of selecting the decimal value, instead of selecting the integer value, we can select the decimal value now. All right, so I can again use the modf module of math library in order to sort of split this number into two parts. So that's going to be math.modf, and over here I'm going to split this number into two parts like this. All right, now instead of going for the index number 1, I'm going for the index number 0. And the next thing that I'm going to do is to multiply this value by 60. Now let's see what we get when we multiply this value by 60. All right, now you get another integer along with a set of decimal values over here. And what I'm going to do now is I'm going to apply this modf module again to this whole thing and dissect this number into two parts. Right, I can do it like this, math.modf. And now this whole thing gets divided into two parts. And out of those two parts, I'm going to pick this integer value over here, similar to what we did before. All right, how do we do that? Now you can select the index number 1. That will give you 20. But again, we need to make sure that this value is also positive. So I can wrap the whole thing in this absolute value command. And finally, as you might have guessed by now, I'm going to convert this into an integer value. That's by wrapping this whole thing inside this integer command. Alright, so this is basically the statement which is going to be stated for extracting our minutes value. Now we can run, and you can see that we already have our minutes value to be 20. So basically right now we have the degrees 103, minutes 20. Now what we are left with is the seconds value. So I'm just going to create a new variable called seconds. That's going to be seconds long. That's going to be equal to. Now if I just flip back to one of the statements that I typed before, which is this one, and if I press enter again, you can see that I'm selecting the index number 1 over here. But now what if I were to select the index number 0? You can see that we actually get this decimal value printed, which is corresponding to this value. And instead of printing this directly, I'm going to multiply that whole thing by 60 again. This is basically going to be my seconds value. So you just pick the decimal component that you used over here, which is this one, and you multiply that by 60, and that gives you the value of seconds. So I'm just going to transfer this statement over here, and also I'm going to make sure that we are getting the absolute value, but in this case I'm not going to transfer that into an integer value because I need the decimal points, because the seconds actually can include the decimal points as well. And now you can see actually we have quite a number of decimal points. So I would also like to limit this number of decimal points to just 3 decimal points. So you can do a simple roundup, or sort of you can strip out the extra decimal points by doing something like this. Seconds long equal to round seconds long. That's basically this. And here specify the number of decimal points that you would like to have. Alright, now let's run this one and see what happens. You can see that I have another variable called seconds long, and that's going to be equal to 6.467. Alright, now I think you might understand that still we are inside a for loop over here. So what's happening is that it's running through each and every row. It's running through the first row, the second row, the third row. It's running all the way up to the station 7, and it's extracting the values of the information of station 7, and it's basically printing out them over here. Now what I would like to do is to not let this loop run without any purpose. During each iteration of this loop, I would actually like to record whatever these findings are into the corresponding place. That means when it's actually iterating over the first row, I would like to sort of record these transformed degrees, minutes, seconds values corresponding to the longitude, decimal degrees longitude value over here, and to put the latitude values over here. So let's see how we can do that. First, you need to specify the location where you need to fill in. So in this case, you're trying to fill in the longitude space. So the way to specify this space would be by doing something like this. You can specify the locations dot loc, and this one is coming with the index, and the column name is, this is the new column name which you are going to fill. That's named as DMS, longitude DMS, and that's going to be equal to. Now basically what you need to do is you need to transfer whatever the findings that you have from here into here. I would like to sort of denote this in the standard format that we write degrees, minutes and seconds. So first I'm going to, right now actually this degrees longitude value is recorded as an integer value over here. So if you want to associate with different characters, you actually have to convert this into a string first. So I'm just going to convert this into a string by just typing str, and inside that I'm going to specify this. Alright, so this one plus. Now here's some funny thing that you might learn for the first time if you haven't come across this. If you want to specify that small sort of a zero sign which is getting associated with the degrees when you denote degrees values, you have to type that in a special you have to type that using some special set of characters. Now if you type this set of special characters, which are u \u00 be 0. And if you print this set of characters, you can see that you're actually going to get this special character which is associated with denoting degrees. So if you want to print this special character right next to the string which has the degrees value, you have to basically include this. You have to basically include this special set of characters over here. I'll leave a space in here. Alright, and now I'm going to actually transfer this minutes value also into a string, str. Minutes, and you know that you can notify minutes by just having one inverted commas. So in Python, if you want to print one inverted commas, the way to do this would be to specify inverted commas like this, and inside that you can actually specify it to be like this. And finally, I'm going to convert the seconds into also a string. You can do that by specifying str, and over here you take the seconds value plus. Alright, now if you wonder what this one means, maybe we can print it out over here and see what happens. You can see that if you want to just print a single set of inverted commas, this is the way to do it. And finally, I'm going to include the hemisphere as well, which we specified over here. It's either going to be E or W, depending whether it's actually located in the eastern hemisphere or the western hemisphere. So I'm just going to specify it as hemisphere. Alright, now we can just run this command and see how it looks. Now if I open these locations over here, alright, now you can see that we managed to print out the degrees, minutes, seconds values without any issue over here. You can see that during each iteration it picked the values from here and transformed them according to the rules that we specified over here, and sort of throw them into different strings as we specified right over here. And you can see that it's quite clear, followed by the hemisphere as well. In this case, all the values are positive, all the longitude values are positive, so that's corresponding to eastern hemisphere. That's what you see over here. And now we can do the same thing for latitude as well. Now if you understand how to do this process for longitude, transforming the whole thing into latitude is actually not a big task. So we'll create another section. Basically, I would say that this section belongs to the longitude. So I'm going to create another section for latitude. Alright, so I'm not going to spend much time on explaining again because the process is basically similar. Just there are some differences. There's going to be some differences in notations. So we can actually copy and paste it over here, but we have to do some amendments accordingly. Now the amendments are going to be basically, instead of longitude here, or over here it's going to be latitude, and over here as well. And if it's greater than 0, now instead of it being east, it's actually going to be north. And over here, instead of it being west, it's going to be southern hemisphere. And this set of code is also actually going to be similar, except for the case that all of these are actually now going to be for latitude, latitude and latitude. And over here, instead of taking the information from the longitude, we are actually going to take the information from the lat. Alright, I think I changed everything accordingly. And finally, printing it out, sort of copying the values to the corresponding column. Just going to paste this one over here, and here it should be latitude DMS. Yeah, and finally these values are going to be degrees latitude, minutes latitude, and seconds latitude as well. And sorry, this one also needs to be changed to be latitude as well. Alright, now we can run the script and see what happens. Now if I open this one over here, if I open that geodata frame, you can see that we successfully managed to convert these decimal degrees values, which corresponds to the longitude and the latitude. We managed to convert that into degrees, minutes and seconds, Eastern, and degrees, minutes and seconds, Northing, in this format quite successfully. So this is basically the objective of this tutorial, to show you how to sort of use a shapefile and extract these decimal degrees values based on the coordinates, and to derive the degrees, minutes, seconds value corresponding to the correct hemisphere in this manner. So now you can either print this one into an external file like a CSV file, or you can even just use a simple plot in order to visualize these points along with this data. So I'll just quickly show you how to do that. So I'm simply actually going to create one more extra column, because when I represent the information in a plot, I would actually like to stack this Eastern and Northing one after another. So what we can do is we can actually create another column called locations. Label, because this is actually going to be just for the purposes of labeling. So first I'm actually going to take the station name, this STN name over here. Alright. With this special character, _n, you can actually jump one row. It's similar to pressing the enter key. That means you're actually starting over from the second line. So you can jump one line by specifying this character. And I'm going to specify plus, and on the second line I'm going to specify the DMS value, the degrees, minutes, second value, which was converted actually from the longitude information. So that we can specify like this: lon DMS plus locations, and finally the DMS values converted from the latitude information. Alright, so I can actually run the script and show you how it looks now. This was actually only for the purposes of labeling these different features. Now if I just expand it over here like this, you can see that it has been stacked one after another. The first one gives you the station, and this one gives you the Eastern value, and this one gives you the Northing value. And similarly for the other stations as well. So I'm just going to transfer this information into a plot. So I'm going to create a new variable called AX, which is going to be equal to locations dot plot maybe the figure size I'm going to specify as 1212. Alright, so I'm going to throw this information actually again into this plot using a for loop. Now you can do that by simply specifying something like this: for x, y, z. So sorry, for x, y, and I will create another variable called label in zip locations dot geometry dot x locations dot geometry dot y locations dot, and the column name that we had for the label is label. All right, and then I'm going to specify ax dot annotate label, and my xy argument is actually going to be equal to x value and y value, and this xy text is going to be something like 5 and 2. These are actually parameters that you can play around, which sort of decides the gap that you have in between the points and the text that you're going to sort of throw into your plot. So later I'll show you maybe in an example what happens when you change these values. And text codes equals to offset points. All right, this one needs to be locations. All right, now you can just hit F5 in order to create this plot. And if I zoom in over here, you can see that we actually managed to extract the information, sort of do the labeling for each particular point. So you can see actually where station 1, station 2, station 3, all the way up to station 7 is located, along with its decimal degrees values. Yeah, just before wrapping up the tutorial, I'll show you what happens. For example, if you put a higher value like 20, and if you run this command, just observe what's going to happen. And if I run this command again, you can see actually the gap increased. So these are the parameters that you can actually specify in order to format your figure. So I'm just going to put this back to B5, and if I run it again, you can see that now the set of labels actually sort of got closer to the point. So that actually concludes the tutorial. It was a bit of a long tutorial, but I hope you learned something new. And if you did learn something new, that's quite good, because that's actually the objective of these tutorials. And if you have any further questions, do not hesitate to comment them down below, and we will get back to you as soon as possible. So finally, I would like to thank all of you for watching, and I'll see you in the next one.